So we left off here where we had determined that we couldn't reject the null hypothesis because 11.6 is not lower than 10.6 or higher than 35. So now we have to find the p-value, and to do that I'm going to right-click, well, highlight and right-click, and I'm going to insert and shift some cells down a little bit here and just give me some space to, some room to groove, as it were, as Rachel Ray would say. Okay, yep, that's fine. And I'm going to unbold and highlight all this. I want no fill. Okay, so what we're going to have to do here is what we had to do way back in 10.3. So in 10.3, you see how we had to do a t distribution value and a 1 minus t distribution value, and then determine which one was better. That's what we got to do here for the two-tailed test. Oops, I never numbered this. This is 10.5, number 15, right? Right. Okay, so we need a chi-dist value. Yeah, that's fine, value. And we need a 1 minus chi-dist value. Okay, so let's see, this is equal to chi-dist. Okay, we tell it this chi-square statistic, comma, degrees of freedom, 21, close. Or we do equals 1 minus chi-dist, there it is, chi-dist. Again, 11.6, comma, 21. Now, whichever one of those is smaller, that's the one you go with. Now, your p-value isn't that value. I know it's a little strange, but it's 2 times that value. What these are is these are the guys in the tails. Okay, so this is the area here. This 0.05 is the area to the left of 11.6, and this, whoopsie, and this 0.95 is the area to the right of 11.6. Notice that the two of them add up to 1. Okay, so whichever one is smaller, that's the one you go with. Oopsie, which I didn't do, which is the 0.05 in this case. That's your p-value. Okay, so if it had been the top number that was smaller, then you would have gone with that, which would have happened, let's say, if this was 34. If this had been 34, then this would have been 0.05, and this would have been 0.95, and right? All right, so that's the p-value. Now, you could also do this same problem with DDXL. Let me highlight the data. Actually, first, before I do that, I'm going to insert a cell right here, insert 2 cells down. I just want to know what sigma squared is, because so often it's asked for by the DDXL and or StatCrunch. So let me just calculate it. It's this number squared. Okay, that's the variance, right? The null hypothesis variance. Okay, so let me highlight the data in the column, go to add-ins, go to DDXL, click hypothesis tests. Okay, we want, there it is, chi-square for standard deviation. Click on the data, say OK. All right, what's our hypothesized sigma? Sigma is not sigma squared, so we'll just want sigma, which is 0.06. So let me go type that, 0.06, OK. Alpha was 0.05. We were doing a two-tailed, so let me click that, click compute, and there we go. Look at the p-value, 0.1014, just like we said. Edit, copy, and paste. There it is, 0.1014. Test statistics 11.6. Now let's do it in StatCrunch. Oops, let me make it bigger. Go to Stat, go to Variance, 1 sample, with data this time because we have the data. It's the apple juice data. Let me click on that. Next. The null variance was 0.0036. It's the variance, not the standard deviation. It was an alternative of not equal to. Calculate. There it is, 0.1014, just like we said. Okay, so either way, we are not going to reject, right? We do not reject H0 because 0.101 is not smaller than alpha, right? P is greater than alpha. Since it's greater than alpha, we are not rejecting here. We are going to let it sit. All right, we're all done. I'll see you in 10.6.